MCEN 1131 Engineering Mechanics Statics Pulleys prepared by Mirko Dumanovic. Pulleys. Pulleys are simple machines that consist of a rope that slides around a disc called a block. Their main function is to change the direction of the tension force in a rope. The pulley system that appears in physics almost always consists of idealized, massless, and frictionless pulleys, and idealized ropes that are massless and don't stretch. The somewhat unrealistic assumptions that we use to analyze pulley system in physics have a number of implications. 1. The rope slides without any resistance over the pulley so that the pulley changes the direction of tension force without changing its magnitude. 2. You can apply the law of conservation of energy to the system without worrying about the energy of the rope or the pulley. And 3. You don't have to factor in the mass of the pulley or rope when calculating the effect of a force exerted on an object attached to a pulley system. The only exceptions to these rules are problems involving torque being applied to a pulley block. In such problems, you will have to take the pulley's mass into account. The purpose of pulleys. We use pulleys to lift objects because they reduce the amount of force we need to exert. To lift mass m at a constant velocity without a pulley, you would have to apply a force equal to the mass's weight, or a force of mg upward. Using a pulley, the mass must still be lifted with a force of mg upward, but this force is distributed between the tension of the rope attached to the ceiling, T, and the tension of the rope gripped in your hand, F. Solving pulley problems. Before we start calculating values for acceleration, velocity, and work, let's go through the 3 steps for solving pulley problems. Start by asking yourself how the system will move. From experience, we know that the heavier mass attached to one end of the pulley, big M, will fall, lifting the smaller mass attached to the other end of the pulley, little m. Because the masses are connected, we know that the velocity of mass little m is equal in magnitude to the velocity of mass big M, and that it is opposite in direction. Similarly, the acceleration of mass little m is equal in magnitude to the acceleration of mass big M, and is opposite in direction. Secondly, choose a coordinate system. Some diagrams on SAT 2 physics will provide a coordinate system for you to use. If they don't, choose one that will simplify your calculations. The standard convention is to designate up as the positive y direction and down as the negative y direction. Lastly, draw free body diagrams. We know that a pulley system will accelerate when released, so we shouldn't expect the net forces acting on the bodies in the system to be zero. Practice problem. Calculate the tension force TA in the pulley system shown below. A solution will be provided to you on the following slide. Homework. Complete the practice examples and problems from the book as well as those provided by the instructor. Also, complete the problems from the textbooks on pages 133 through 140. Use the trigonometry formula sheet provided by the instructor.